So I was walking in a bar. Then I came here. No. Okay, welcome to DevOps from Malmö. So we are live streaming this event from Foo Café that is helping us streaming this. DevOps Malmö is a meetup group, and we are all over social media. Just Google it. I'm not going to talk so much. I'm going to give this floor to Jakob from Verifa. He's going to talk about, well, managing multi-Kubernetes clusters. So, Jacob, thanks, Steve.
Thanks. Okay, hopefully my mic is working. In fact, I can hear myself, so. Yeah, really nice to be here. Like Albert said, I'm going to give a talk about managing multiple Kubernetes clusters with Argo and CD, so hopefully it's nice. If you have questions during the talk, please feel free to ask. It's not so well prepared in the sense that like I know everything I'm going to say beforehand. It's more like I have cues, so it's just fine if you have questions. And yeah, bit about myself. I'm nationally confused. I was born in Sweden and grew up in England, and then I lived in Europe, and now I've lived in Finland for almost as long as I lived in England. So if you ask me where home is, I don't really have a good answer. I'm CEO of Verifa, and I spend most of my time doing consultancy work there, and then the rest of the time doing everything else that role entails. And I was just here in Lund visiting the lovely new office and lovely new colleagues and things, so that's great. And I'm a happy father since 11 months ago, so that's my little Hilda, and that's changed my life, but all for the better. And yeah, now I have to prioritize my work even more because suddenly I have even less time to do what I want to do. And really briefly about Verifa, we're a team of consultants doing continuous delivery and cloud architecture. So we work with major clouds and Kubernetes and a lot of HashiCorp things. And yeah, we like to think that we're a little bit different because we want to actually change the way people work rather than just coming in and doing lots of work. And what I'm going to talk about today is the project that I'm involved with, where I have been working since September time. So I can't talk too much about specifics of the project because it's a customer, but I think this is more like general knowledge that is nice to share and nice to talk about. And if you want to talk with me afterwards about it, I'd love to learn from you and talk about what I've done, because that's one of the reasons I give this talk, is to learn and better myself as well. So. Cool, so why not just one big Kubernetes cluster? I mean, this really depends on context as well. That are you working in a project where you run just your workloads and nobody else's workloads, or if you're running or administrating Kubernetes cluster and running other people's workloads on it, the situation depends a lot. We're in a case where we're running Kubernetes as a service in a way that we provide a cluster for teams who don't need to worry about the nitty-gritties of Kubernetes to just deploy their workloads on. So when I joined the project, we had one big cluster, which was managed with not using managed Kubernetes service, and the idea was to use AWS EKS. So the idea was that instead of just replicating what we have and putting it into one big EKS cluster, how about thinking about running multiple clusters, because there's certain advantages to that. And most of the disadvantages are not gone necessarily, but if you're running your own cluster manually, well, you might be using something like COPS or building it with kubeadm or something, but still you're responsible. And there's a lot of overhead and a lot of risk that comes with that. So maybe you only want to run one cluster because then you only have one thing to fix. But if you're using a managed service and you can use things like Terraform to just create clusters, then why not start to run more than just one cluster? And the main benefits there is that you can really separate concerns. Sure, you can create namespaces, sure, you can create node groups, but if you really just run separate clusters, then there's no way those can interfere with each other, so it makes a lot of sense. Doing things like upgrades as well is easier because you can maybe just test an upgrade on one of the less critical clusters, or spin up a dev cluster and test an upgrade on that, rather than upgrading, the one cluster where if that fails, suddenly everything is on its knees. So that's, I think, the use case behind multi-Kubernetes clusters. And again, it depends a lot on your use case. I mean, if you're only running a cluster for your own workloads, then maybe you don't even need to think about this. But if you are running other people's workloads, or you're running workloads in different regions and things, and you just feel like there's a need for this, then that's the use case that we had. And the complexity with running multiple clusters is obviously you have to now run multiple clusters. So that can be alleviated a lot through things like infrastructure as code tools, like using Terraform to create the clusters, and then using ArgoCD to provision the workloads on the clusters and prepare a cluster to be ready. And I was new to ArgoCD when I started this, so I've only been working with it now for like 7 or 8 months. I had worked with FluxCD, V1, and well, Helm and Customize and all the other tools that you can think of, but not the true GitOps tools that sit and listen to a Git repository and reflect that in your cluster. But I have a couple of points in here about maybe not differences, but things that I really like about ArgoCD. So yeah. What is a ready Kubernetes cluster? I mean, you have the managed services, and even AWS now is starting to add add-ons to the Kubernetes cluster. So you can, even in the Terraform module now, or in the console, you can tick boxes and say, okay, I want these extra things, like I want the new EBS controller so that I can use the optimized GP3 PVCs and volumes. But still, you probably need to install some stuff so that you can actually use your cluster. Mostly controllers, like you need an ingress controller. You might want something to do with networking. You might want your monitoring stack deployed on there. You might want, well, they're on the thing. But these are the ones that we use, so it's not just create a cluster and it's ready, but we need to do a number of different things to get the cluster into a point where it can actually be used for production workloads. And this has a bit of a overhead, because if you're managing one cluster, it's very easy to manage one thing. If you're running 10 plus clusters, or even 5 plus clusters, then suddenly you need to do this on all of your clusters. And how do you do that is a really good question, because you don't just want to push stuff to the cluster and say, okay, it's there, it's running, it's done. You want to know that it's actually still running, and if you update it in one place, like a git config, you'd probably want that to deploy and run out across all your clusters and not just one, and then manage it for each individual cluster. So really briefly about Terraform. I don't want to go into too much details about how it works. But if those of you who haven't worked with Terraform in the past, you basically write some HCL code. You can do it with the, what's it called, the TFCDK thingy now, so you can do it with actual code. But anyway, I use HCL, which is the hash called config language, and we declare the providers we're going to use, which are like the plugins to tell us how to talk with AWS, for example. We define the resources we want to create in AWS, and for that we actually use modules like the, well, that's flickering up and down, that's annoying. But yeah, we use the AWS EKS module that's maintained by, well, the community, so that we can create EKS cluster quite easily. And then, well, we define a few other things, and then we run an init to initialize the backend, run a plan to say, okay, this is what we're going to create. Then you run an apply to actually create those resources in AWS. And when you apply stuff, it's written to a state. So that means that if you remove something from your config, it gets removed from AWS when you apply it next time. So basically, what you define is what you get. And if you remove something, it knows that you've removed it. Then you can create a bunch of cloud resources. So we use this for creating all sorts of things like the application load balancers. I actually ended up having a pre-existing VPC that we needed to use, so we used a data source to say here's an existing AWS VPC that we want to create the stuff in. But then use it to create the EKS clusters, the node groups, which we're now using EKS managed node groups, and basically create the foundation for the Kubernetes clusters. And to keep things dry, we create our own Terraform modules for these things, so that instead of duplicating all of these resources over and over and over again, we create a module which we call EKS, which then ends up invoking the community EKS module, but it does some extra little things for us as well, so that we can quite quickly now create a new EKS cluster just by invoking our module that we've created. So it's like writing a function in a programming language. You write the function once and create some parameters, and then you can invoke that function as many times as you want without having to write out the whole block of the function. We're doing the same thing with Terraform, just creating a module with our resources, creating some variables, and then we call that module. So that's Terraform very briefly, and how we're using it for this. And ArgoCD, which is I don't think I've taken a liking to a tool so much in such a short period of time. I'm an ArgoCD fanboy. It's really amazing. But yeah, to give you a really quick high-level overview, trying to figure out where I can stand so people can see. You have a Git repository, or many Git repositories. Anyway, there's Git repositories where you define Kubernetes manifests. For the most part, they are standard Kubernetes resources like secrets and config maps and things to define the ArgoCD deployment. But then ArgoCD has custom resource definitions for things like applications, which are probably the main point in ArgoCD, that you create applications to say, I want to deploy some collection of resources. And then there's things like projects and well, that's pretty much it, because clusters are just a Kubernetes secret with an annotation. But anyway, what ArgoCD will do, if you tell it to, is to listen to a number of Git repositories, sync those, use webhooks, whatever, to get changes, and then it will be connected to one or more Kubernetes clusters, and it will, it's a controller, so it sits and listens for things like if you create a project or an application, and then it will do something like deploy something or update resources in that Kubernetes cluster. But then what it also does is it reconciles the state within that Kubernetes cluster to check that what you actually wanted to do in your Git repository is what's actually running within the Kubernetes cluster. And I think for me, when I started working with ArgoCD and Flux back when, this point was kind of like a nice to have, but I feel like nowadays this is probably one of the most important things for me, and it's the difference between having a CI pipeline push stuff to a Kubernetes cluster where it pushes and it forgets until the next time you run the CI pipeline, and it pushes more stuff to the Kubernetes cluster to say run this stuff. Because what this does is if you push something and something changes in the Kubernetes cluster, it's going to tell you that something has changed. Something's out of sync with what you're wanting to do. And I mean, very rarely does anything really change, but just having that confidence to go to a dashboard and see that, okay, this is what I wanted to deploy, and this is actually deployed, and it's in sync, and everything's fine, is, it gives me confidence to work with Kubernetes more and more. And yeah, I'd probably say that that's like really, really valuable thing. One of those things that once you start doing, if you imagine going back to how you were working before you had that, you'd be like, whoa, like, so I don't actually know what's running there. Like, is it in sync? Is it not? That like fear of not knowing. So that's really great. And in quite a recent version of ArgoCD, they now included these application sets in with the basic deployment of ArgoCD. So Argo is actually a collection of projects, and ArgoCD is just one of the sub-projects. And within ArgoCD, they have more sub-projects, like application sets was a separate thing that you needed to install together with ArgoCD, and now it's part of it. And application sets, what they do is they template applications for you based on like generators, which could be, for all my Kubernetes clusters that ArgoCD can talk to, create this application. And it's the key to managing multi-clusters with ArgoCD, because an application is pointed to a cluster and something to deploy. So how do you do that with multiple clusters? Well, you create an application set that defines the application and points to all your clusters that you want to. So that's really, really nice. And I think, oh yeah. So this is, well, yeah, and the best part of all, it has a UI. So I mean, ArgoCD came out, and Flux version 1 came out around the same time, and they were the two main GitOps operators within the Kubernetes ecosystem. And choosing between them was not like a good decision or a bad decision. The team I was working with, we started working with Flux, I think because it was a bit more low level and it felt a bit more just connected with everything that was going on, and ArgoCD was a server and it had a UI and it had overhead, and I don't know, it just felt like more. But from what I see and from when I speak with people about why they chose ArgoCD over Flux, it was because it had a UI. And that might sound a bit like shallow because you're in the terminal anyway deploying Kubernetes stuff, but it's, again, this view of your Kubernetes clusters and your applications, and they're in sync with what you've defined in your Git repository, is beautiful. And Flux does have a UI, but you have to pay for it. And, well, we all know what it's like to have to pay for something, because it's not just money, it's speaking with people and getting a budget and why do we need this tool and blah, blah, blah. Whereas you could just run ArgoCD for free. It has the UI with it already, and it's a really useful UI. I'm going to give a little demo of it if you haven't seen it before. So I think this is kind of funny because, from my opinion, this is the main reason why ArgoCD is more popular than FluxCD, because it just comes pre-packaged with the UI. So here's a demo that I didn't put together. I already opened this up. So if you go to cd.apps.argoproj.io, there's the running instance of ArgoCD, which is maintained by the Argo project, and they have a bunch of applications on here, so you can kind of like see what's, or you can get a feel for it and have a look at what they're running here. So if we take this, each of these blocks is an application. If we take the ArgoCD application here, and you can see that everything is green, so green is good. It means the application is healthy. Since the last, the current version of what we want to deploy is in sync with what's in the cluster, and the latest config that Argo received to sync is also in sync. So those are the three health indicators there. And what we get is a tree of all the Kubernetes resources that are created from the application. Somehow this isn't folded up with all the versions. You can configure, these are all different revisions, which is why there's a lot of bloat here, but usually this is a bit cleaner, and you can configure it to say how many revisions you want to see. But this is basically the tree of, I have my application, and then these are all the Kubernetes resources that get created when I apply that application. So this is your deployment in Kubernetes resources. And especially for people who aren't so technically savvy with Kubernetes, this is really nice. Even if you are and you use K9s or something as a terminal dashboard, I still go to this all the time, and just when I make a Helm deployment as a test to check to deploy something, I still go to this and just have a look and just it's happening, and you can see it, and when it goes green, you're like, okay. Or it goes red, and then you can just click on it and see that, yeah, this is failing for whatever reason. It's just really nice. Yeah? Yeah. Yeah, yeah, yeah. I think of. Thanks for pointing that out, because I think. Oh. Yeah. So, if you want a visual representation of the flow of data, I mean, you have your endpoint and then your ingresses, which point to your services, and then down to your actual workloads. You can get that in a visual representation as well. Which, if you're not super in the know of Kubernetes, or you're a developer and it's just like you don't need to know that much, ArgoCD is really nice, because I mean, anybody can understand this in a way. You could read the 101 on Kubernetes, and okay, pods are where my containers run, and then I have a service and an ingress. So I really see a lot of value in this. Thanks. I think I'll jump away from the Argo UI now. That's basically the gist of it. You can actually create stuff. I don't have permissions here. Oh, well, I have permissions to press the button, but it won't work if I actually do something. You can clickety-click and create stuff from the UI to create a new application, but I've actually never done this because I just prefer to write in YAML, and you can kubectl apply -f and pass your application locally from your YAML file. You don't have to do everything via Git. So usually what I do is I would write the YAML file, define the application, the custom resource definition, and then apply that by kubectl apply. And then when I'm ready to move that into Git, either I delete everything, so delete the application and tell it to delete all the Kubernetes resources it's created, and then put it into my current Git repository or a Git repository which is being synced, and have it be recreated. Or I just make sure that the application name matches what's going to be created when I move it to Git, and then move it to Git, and when ArgoCD syncs, it's like, yeah, the application already exists and won't do anything. So that's like, that's nice. But yeah, if you like to just click through and do stuff, you can. You can even edit it as YAML here. I have some example application manifests and an application set manifest as well, so we can have a look at those and see like what they actually are. Yeah, so when you deploy multi-cluster environment with ArgoCD, there's two main models that you can follow, deployment models. So either you can run one central ArgoCD instance, and that connects to the other clusters and can deploy stuff, can delete stuff, can basically manage the deployments or applications on there. Or you can run ArgoCD on every single cluster. I mean, there's no right or wrong answer. People argue that 0.2 is much better from a security perspective, because nothing should ever really need to talk to a cluster, because everything's happening from within the cluster. We went with option 1, and I kind of prefer option 1 in a way, because you have your one ArgoCD instance, your one UI, where you can see all the clusters and you can see all the applications. Whereas if you do it per cluster, then it's kind of separated out, and I don't know if there's a probably you can build like some Grafana dashboard to get everything in, but at least I don't know of any out-of-the-box way of getting that single pane of glass with everything on it. So we went with option 1, and this is the like main slide with stuff on it. So we created a, and this is just our convention. I think I found this online and adjusted it a bit myself. But we have a root cluster. So the root cluster is where we run ArgoCD and also other services that the clusters that we create depend on. So for example, things like HashiCorp Vault for secrets management that all the other clusters need could be running there. And then on the left-hand side, we have a Git repository with our infrastructure. So this is mainly Terraform stuff. And then on the right-hand side, there's another Git repository called apps, and this is where we define the Kubernetes manifests, which define the ArgoCD applications. So this is just what we have done. So there's 2 main Git repositories. And yeah, like I said, the infra side, we have our directories with our different Terraform root modules, which basically we have a name of a cluster and then prod or dev. And within each of those, there's a cluster directory, which contains the stuff to create the actual cluster, and then the add-ons, which creates things like the Kubernetes secret, which is the thing that tells Argo that, hey, this cluster exists, and also sets up the IAM roles, which ArgoCD can assume, so that it can authenticate with the other Kubernetes clusters using IAM roles for service accounts, the IRSA four-letter thingy that if you work with AWS becomes a pain to say, but that's how you communicate in an AWS native way with other Kubernetes clusters. So there's 2 modules. The reason for separating these is that you shouldn't create Kubernetes resources through Terraform from the same life cycle that you create the cluster, because it can lead to issues. There's like nested in deep GitHub issues, there's actual people writing why. But it's like if you change something to do with the cluster, then it can't apply the resources because it doesn't know it's to do with like the known states of the Terraform resources you're creating or something like that. I feel like I read it and I'm like, I get it, and then don't do that, and then next time I have to explain it, I forget why, but it's something like that. So that's why we have 2 directories, and in the add-on stuff we do all the the add-ons, like IAM roles for all the different things we want to run. So in some clusters we run the EFS controller so that we can provision the Elastic file system, which is one AWS file storage, so that when the cluster installs the controller, that controller assumes an IAM role, and that IAM role has then the permissions to actually create or destroy access points to the file system, and same with EBS, that it can create the Elastic block storage based on the IAM roles that it can assume. So it's like the extra stuff that the Kubernetes clusters need to do. Arguably, it would be very nice to actually move these add-ons probably into the Kubernetes cluster, using something like a controller that can apply Terraform, because they are a bit specific to each cluster sometimes, and it's an idea we have, an improvement we'd like to make, and if I had unlimited time to do this, I would probably try and figure out how, but anyway, for now, this works fine. So yeah, we create the cluster, we create the IAM roles and the extra things that the workloads need, and then the root cluster, which is where we run the single ArgoCD instance, points to, well, in this case, it could be one Git repository, and in here we deploy a bunch of applications and application sets that then get deployed into the other Kubernetes clusters that we manage. So some of these, for example, the Datadog agent, so if you're using Datadog for monitoring, then you would deploy the Datadog agent on all of the clusters, because probably you want monitoring on all of your clusters. Other ones like the EBS CSI driver, it runs on all the clusters where we have a label with something like EBS enabled equals true, and that label is set in this secret based on some inputs to the things. So we can kind of like, I would say in a nice way, say which of these application sets should deploy on all the clusters and which should deploy on only the clusters where it's actually needed, so that we don't just blindly install everything everywhere, because some of these things run daemon sets as well, like the EBS CSI driver runs a daemon set, which means a pod on every single node in the cluster so that it can mount the file system. And well, when you start to have like 10 daemon sets on every single node, then well, you can't really run small nodes anymore, because you already have 10 pods before you've actually done anything useful. So that's the reason. And then yeah, we have tools like Grafana and Vault, which run on a specific cluster, and those are just applications, not application sets. And yeah, we have a bootstrap directory which includes the ArgoCD application itself. So this is kind of funky, but seems to be what everybody else is doing, and it works well. Which is that to like, if we deleted all this and wanted to start again, we would create the root cluster, and then I have a little README in the bootstrap directory which says run this command and run this command, and it deploys ArgoCD and connects ArgoCD to this repository, and then now if we make changes to ArgoCD, ArgoCD deploys those to itself. Yeah. Yeah, it's like Inception. And it sounds really funky, but people are doing it, and I read lots of people doing it, and lots of people being like, isn't this a bit weird? I'm like, yeah, but it works well, and I echo that. It sounds a bit funky, but it works really well, so, yeah. And then, yeah, we define projects as well. So projects are more to do with like role-based access control for ArgoCD, that you can define which clusters a project can deploy to. So if you start to have tenants or this sort of thing, you could say that, okay, this project and members of this project can only deploy to these select clusters. So you can't just deploy everywhere based on who you are. But I think running this in a kind of multi-tenant setup where you have users, nobody should have access to the root cluster to just kubectl apply, because they could, well, change this stuff. You should have Git repositories where they would pull the configs from, and then you can have some control over what actually gets deployed, because all of the applications, the application sets, the projects, which is another ArgoCD custom resource, all of those have to get deployed to the root cluster, because that's the only place where ArgoCD is running. So that's like something to consider. How are we doing for time? 10 minutes. Okay. I mean, I said all I wanted to do here, but should we? You have multiple questions. If we have 10 minutes, I could probably finish this, and then if people want to continue afterwards, we could continue, or we could just have a beer and chat about that, and people can eavesdrop or whatever. But if we have 10 minutes, it's enough time to maybe run through this, and then the formal part is done. Cool. Teeny tiny YAML with this blocking out. You can see this kind application here on line 2. So that's the custom resource. That's an application. And you can say, point to a Git repository, deploy a Helm chart with some values. Yeah, like basically, where's your, how are we going to render your Kubernetes manifests to deploy? That's basically what you say. And you say to which cluster and which project you belong to, that sort of stuff. And then the application set is basically a application. So this metadata from, where are we? Metadata from here is the same here, but we have the actual metadata which tells it where to deploy stuff. So it's just an application within another Kubernetes resource called an application set, which will template this, and you can see here we like template the name of the cluster. So it's that simple, and it's really nice. And I don't know what I would do if we didn't have this. I mean, probably I could deploy stuff from Terraform, but I don't really like doing that. And otherwise, I'd write some automation for deploying stuff somewhere. But this is just so easy and beautiful and nice. So I rate application sets. And now they're part of ArgoCD in a native deployment, so that's good. What's that? Oh, yeah, well, yeah. Yeah, well, yeah. I'm flexible.
So where did the placeholders come from? So the name, and how many can you put in there?
Yeah, so generators are the things that application sets use to generate the placeholders. And you can, there's a bunch of different generators. Here I use the clusters generator. So ArgoCD knows about clusters because we create the secret which tells it about the other clusters. So there's a secret per cluster. So it knows about clusters, and we say for all the clusters that have this label on it, which looks a bit funky, but what it means is give me all the clusters that exist with this secret. So not the cluster itself where Argo is running, but all the other clusters. But actually, we add a secret for the root cluster as well, so it actually includes all the clusters, but yeah. But you can do things like read a JSON file from a grep and use the values from a JSON file as potential values that you can override. And this is quite nice if you want to override settings like the project and things, and you have a common deployment. And you can just define a list, a static list with like values. So it's, yeah. And yeah, there's so an app is quite a primitive thing in ArgoCD. In fact, what I missed from Flux was that when you deploy Flux in a cluster, you have to point it at, or you point it at a Git repository, and it just goes and explores and deploys the stuff that it finds. Whereas an app, you have to create an app to do that, but then to actually deploy something, you need more apps within that Git repository. So you can't really do anything meaningful in ArgoCD without having an app pointing at another app, and that's called the app of apps approach. But it's not quite that trivial or that simple. And what we have, and this isn't really like completely what we have, but we've got like an app of an app of an app pointing at some customized stuff, which points at more apps, and those apps might point at application sets, which then template more apps that actually deploy stuff to the clusters. And it sounds horrible. And it's another one of these things where at first I was like, well, that sounds really funky. Do I really want to do that? But once I started doing it, it's actually like totally fine. The only exception being that you can set a finalizer on the applications to say delete all the resources that this application created if the application gets deleted. And you can really like put yourself in a mess if you make a tiny minor change and suddenly all your applications change name, or all your applications get deleted, and you got the finalizer on there and all your deployments are gone. So so I don't add the finalizer. I add the finalizer when I need to delete stuff, but by default it's not there, so that if I made a mistake it wouldn't just delete everything. It happened once, and we run Calico for networking, and good luck having a production or even a Kubernetes cluster that works without networking. Yeah. And yeah, there's a fun project called Autopilot, which was written by the Argo project, which bootstraps a Git repository with a template for application sets and kind of like a multi-tenancy setup for using Argo. And it's actually this directory of having apps, bootstrap, and projects is based on what the Autopilot tool generates. It fitted our use case quite well, and that's the only thing I got from Autopilot. I had already done everything else when I found out about this, but it's kind of nice to have a reference, because I feel like if more people start adopting this and doing it the same way, then you can look at any other ArgoCD Git repository and see that, okay, there's apps and there's bootstrap and there's projects, so it just makes sense to follow conventions and do it the same way. But if you want to like try ArgoCD and do something real with it, once you get past the 101, deploy it and have a play with it, I'd look into this Autopilot, because it just gives you a ready idea of what you can do with ArgoCD, and better to follow what others are doing than just invent your own crazy stuff, because yeah, so yeah, I guess that's the bulk of the talk. I have a few extra things I could talk about, but I'll wrap up here. So Yeah. Multi-cluster is nice for separation and has certain advantages, but it adds the overhead of having to manage multiple clusters. So managed Kubernetes services are great because that reduces a lot of the work, and then if you use things like Terraform, or you could use Pulumi or CDK or whatever to create the clusters. And then ArgoCD is really nice because how do you maintain all these deployments, which might not be actual workloads, but more just what you need to run on a Kubernetes cluster for it to be usable. That can be done really easily with ArgoCD. So that's my learnings and my recipe that I use daily, and it's nice. And I'm done.
So, questions from the audience?
Thank you very much. My first question is about the templating these app sets. You showed you could have different ways of creating these loops of what you wanted to generate.
Yeah.
And you showed you could have it from files and so on. If I, for example, have an application that is gonna sort of supersede a sort of on-premises Linux machine that has containerized apps, and I want to actually create like 15 of those guys, but they can't really only run RESTful. They want to have some load balancer or something. Can I actually have something that, without like copying this application 15 times, can I just say, make according to this list, I want this many, and I want them to have these unique names, and I want to do ports in this way. Can I get that from here?
Yeah. So just to be completely clear, that all this application is going to do is deploy some Kubernetes resources. So you need Kubernetes clusters running.
Right, I have my Helm chart ready.
Yeah.
But I don't want to make like 15 folders in ArgoCD and 15 applications.
Yeah. So then you could do it exactly like this. Is exactly the use case for that. This is exactly the use
You're
case.
going to save me a couple of months of work.
Yeah, it's genius. I would. In some cases, it's easier just to have a static list. Like we run KubeCost, which is a cost monitoring tool, and it's a bit funky how we have it set up because we haven't paid for it yet. I'd like to pay people, but you need a proof of concept and stuff. So we deploy it with an application on the main cluster, and then we have a list of clusters where we want to deploy the kind of like agent, which is just the same thing again. So we just maintain a static list there because it's easy. For the tools where it's more like opt-in for something, then we use the labels. So it's basically doing a match labels, and if my application should be deployed here to equals true, then the application set will render it, and that's based on the secret. So this is just a Kubernetes secret that you create in the root cluster, and it tells ArgoCD that okay, these clusters exist, and here you can add these labels. So that's more of a like dynamic, clever way of doing it. Clever, not necessarily being good, but yeah.
Right. So the reason I was asking is because this application, I mean, many of our applications are multi-tenant, but this one is not.
Yeah.
So then I wanted to like, all right, I have this many tenants, please create that many, without me creating a lot of, bloat.
Yeah. Yeah.
Right.
So that's
Perfect.
exactly the use case. Yeah.
Got it verified too. I was just buying time.
Everyone wants to hear your question really badly, so they're like, yeah.
Oh yeah. So my second question is, you spoke about having this role-based access and different things that you want to let people do. What is your preferred way of adding other users? For example, if you're using something like I'm using Azure and we have Azure Active Directory,
Yeah.
how do I onboard my developers?
Yeah, so the ArgoCD's RBAC model is not the same as the Kubernetes native RBAC model, and that is a topic of huge debate. Some people are like, oh, this is the worst thing about ArgoCD. But there's a Go library called Casbin, which is what ArgoCD uses to manage the RBAC. And there's an OIDC provider built in, but it also uses DEX, which is an OIDC proxy, so it can talk to LDAP, it can talk to Azure AD, it can talk to Google, GitHub, GitLab, whatever, and basically proxy that into the OIDC provider. So you can get your users from many places, and then you can define your scopes for the, like, what you define as groups. So if you have groups in Azure AD, for your app reg, then you can get those groups into ArgoCD, and then you can define what roles those groups have based on your Azure AD app reg.
Right. Would I do that via the projects to define what the different groups in AD would be able to do?
Yeah, so the connection with OIDC goes in the app ArgoCD. I actually deploy ArgoCD using the community maintained Helm chart. The official Argo proj deployment is to use Customize, but we use Helm for all the other external stuff that we deploy. And I have a lot of beef with Helm, but it's also very convenient, and it's very convenient for this. So you can define the config map, which does this for you, and then you get your users and groups, and then you can define the RBAC in that config as well. Yeah, I think you define what the groups can do, but then and which projects they have access to. This might be wrong, but I think that's how you do it. And then in the projects you can define which clusters they have access to. So everything to do with users, groups, and which projects they have access to goes in the ArgoCD root deployment. And that's a bit of annoying because currently there's only support for the one config map. So you have to update the config map. I think there's an issue open somewhere to make that customizable.
I think this might have turned too much specific to my case, but how would you, for example, do it for one of your clusters when you're running on, say, AWS instead of Azure? What would you do in your case to bring your users in?
Well, add them to a group if we have that capability in Azure AD, and then assign them to a project, and then define in the project which clusters they can deploy to, or which namespaces they can deploy to. Can they update? Can they delete? Can they, what's their capability? The guy wearing the Argo Proj t-shirt. So this has got to be a good question. Yeah. It's like, I think pizza was ready now, right? Yeah.
So thank you for the presentation, of course. And my question is, since we are talking about GitOps, so the idea is to avoid this, the situation where there's manual fiddling and the application could change. So why would not do that also from the infrastructure? What do you think about that?
Well, technically we are doing GitOps with Terraform, just not using a Kubernetes controller. So the changes that are made to the Terraform repository can be applied automatically. We're actually not doing that right now, but it's in the works. So we would have a change to Git, and then it would apply the stuff using Terraform Cloud, or if you run it in CI, you can just run Terraform from there. So it is technically GitOps, but the push-based kind of GitOps. There's no reconciliation stuff, or no drift detection.
And the other thing is that we don't have everything in Git, because the single source of truth would be the Terraform state. That is not in Git. So you are missing one of the principles of GitOps here. But yeah, most likely it would be the same, since you have automated the process.
Yeah, I mean, if we lost the state, we would be able to. Well, it's always a fiddle to recreate state, but I mean, we have the Git config which defines everything we want. So there's nothing that exists in AWS that isn't defined as a Terraform resource. But the state is just how Terraform works. So.
Thank you.
Yeah. But I think this idea of running this, at least some of the stuff with something like cross-plane, or there's a couple of Terraform controllers. I think I saw 3 Terraform controllers for Kubernetes come out in the last couple of months. They're in beta or alpha, so there's nothing really mature yet. I think one of them is from the Argo project, and it uses crossplane under the hood, or parts of crossplane. So it would be really cool to move these add-ons to a controller in the root cluster, or maybe even the creation of the other clusters. I mean, yeah, it's one of these things where you try and perfect it too much and you don't end up actually doing anything useful, but just changing your mind every couple of days. So I'm happy with this. It could be improved, it could be criticized, but it works and it's nice. And I've spent a lot of time telling myself that it's okay that it's not perfect, because I like to perfect things. Yeah.
Okay, thank you very much, Jacob.
Yeah, thanks for listening. Awesome.